2.1 The idea of limits. Suppose a stone is launched vertically upward with an initial velocity of 96 feet per second from the river. By Newton's laws of motion, the position of the stone measured as the height above the river after t seconds is s of t equals negative 16 t squared plus 96t. And that is our position function. It gives the number of feet above the river at time t. Average velocity is displacement over time, displacement over the change of time. Suppose we'd like to find the average velocity of the stone between 1 second and 2 seconds. We first find the position of the stone at 1 second. Then we find the position of the stone at 2 seconds. What is the displacement change of s? The difference between 128 feet and 80 feet is 48 feet. What length of time does it take for the stone to travel 48 feet? That is, what is the change of time? From 1 second to 2 seconds, and a complete 1 second has occurred. So, what is the average velocity? The average velocity is the change in distance over the change in time. And so 48 feet per second. Let's look at this geometrically. We found the change in height, and we found the change in time. And so the average velocity is just the change in height over the change in time. Notice that what we also found is the slope of the secant line that runs through the point 180 and the point 128. So average velocity is the same as the slope of the secant line. The secant line being the green line that runs through the curve at 2 locations marked by blue dots. Okay, suppose we'd like to fill out this table. Notice that in the table our starting time is always at 1 and our finishing time is 2 and then 1.5 and then 1.1, and it is getting closer and closer to our time of 1. We already found that going from t equals 1 to t equals 2, we found that the average velocity is 48 feet per second. So let's find for the time interval 1 to 1.5. Well, at 1.5, the position is 108. All right, so 108 minus the position at time 1, which is 80, and I get a change of height being 28 feet. Now the change in time this time is half a second. So now my average velocity is 28 feet is traveled, and it takes a half a second for that to occur. And so my average velocity is 56 feet per second. And then we'll just go ahead and fill out the rest of the table. Notice that as t1 approaches t0, so the second number of the interval is approaching 1 second. So these time intervals are getting shorter and shorter. Notice that as that happens, the average velocity is getting closer and closer to 64 feet per second. But for that reason, we say that the instantaneous velocity is 64 feet per second. And I just introduced a new notation, that limit notation, LIM. And what it means is the average velocity, as that second number was getting closer and closer to the first number, our average velocity is getting closer and closer to 64. And that is instantaneous velocity. Okay, also let's go back to the slope of the secant line. The secant line is the line that runs through the graph on 2 points. And it is the change in height over the change in the horizontal distance. So it's just rise over run. And here too, as T1 approaches T0, the slope of the secant line, rise over run, is getting closer and closer to 64. And so what we say is the slope of the tangent line is equal to 64 feet per second. Here's a graph that might be helpful to you. There's the green line is a secant line. And what we're trying to do is we're trying to bring those two blue dots closer and closer to each other until I can get a good approximation on the slope of that tangent line. And so the approximation on the slope of that tangent line is 64. So just to recap on what's in this section. In this section, we discussed the slope of a secant line, which is just rise over run if you make a secant line, which is a line that goes through the graph at 2 points. We also discussed average velocity. Then we said that the slope of the tangent line is the slope of the secant line where the 2 points are getting closer and closer together. And instantaneous velocity is average velocity where the time interval is getting shorter and shorter. Take care and have a good day.